Okay, so we will start with another numerical. So solve uxx plus uyy equal to 0, that is dabba 2u upon dabba x square plus dabba 2u upon dabba y square equal to 0 for the following mesh with boundary values. So here you can see that a mesh is given to you, and in that mesh you can see all the boundary values are given to you, and you need to find out the value for u1, u2, u3 and u4. So these 4 points you need to find out. And first of all, as I mentioned previous class in the previous class, that you need to find out first of all the primary values, and then by doing number of iterations you can increase the accuracy of these answers. So when you look at this mesh, so one thing you can say that just like previous problem, this is not, there is no symmetry in this problem. So you cannot apply any symmetry rule for this, and independently you need to prepare the equations for u1, u2, u3 and u4. But again, once you prepare the equation, or while preparing the equation, there is a question either to go with diagonal 5-point formula or standard 5-point formula. For example, if you go with u1 and if you apply standard 5-point formula, then 1 by 4 into 1000 plus 2000 plus u3 plus u2. So again, you can see in this equation there are two unknowns, u2 and u3. So directly you cannot use standard 5-point formula. Then we will check, can we use diagonal 5-point formula? Then in that case, u1 will be equal to 1 by 4 into bracket 1000 plus 2000 plus u4 plus 1000. Again, in this equation as well, u1 is unknown. So it seems that even with the use of diagonal 5-point formula, you cannot find out the initial values, or you cannot solve. So this is a bit tricky question, because in previous case there was an option that initially you can use whenever possible standard 5-point formula and diagonal 5-point formula to calculate the initial values of u1, u2, u3, u4, and then for next all iterations you used standard 5-point formula. But in this problem, that is not the situation. So what we need to do? So we need to apply only standard 5-point formula and prepare equations for u1, u2, u3, u4. So you can see here u1 is equal to 1 by 4 into u2, here u2 is there, plus 2000, so 2000 plus 1000 and plus u3. So this is the equation for u1 by using standard 5-point formula, and in this equation there are two unknowns, u2 and u3. Similarly, prepare equations for u2. So u2 is equal to 1 by 4 into 500 plus u1 plus 1000 plus u4. So this is the formula used for calculating u2. Again, in this equation, u1 and u4 are unknown. Then for u3, so u3 is equal to 1 by 4 into u4. So u4 plus u1 plus 2000 plus 500. So this is the formula for u3. And similarly for u4, we can prepare similar formula. So you can see U4 is equal to 1 by 4 into 0 plus U3 plus U2 plus 0. So this is the formula for U4. Again, in this equation, there are two unknowns. So when you look at all these equations, you can easily say that we have prepared four equations by using standard 5-point formula, but in each equation there are two unknowns and we don't know their values. Again, if we try to apply diagonal 5-point formula, again we will get the four equations, but in each equation there will be at least one unknown. So again, there is a problem to solve the problem. So what to do? We need to move ahead, and first of all, we need to simplify that equation. How? So U1, in case of U1 equation, you can see you can add easily 2000 plus 1000, and we can write down the equation as U2 plus U3 plus 3000. So we can simplify this equation, so that once you simplify this equation, you will be in a position how we can tackle this particular problem. So these are the simplified version of the four equations, 1, 2, 3, 4. Now we will see what to do, and here important thing is that initially we need to assume few values. So solve above equations by using Gauss-Seidel method. Consider U1 equal to U2 equal to U3 equal to U4 equal to 0. So what we are going to do, as we cannot solve these four equations, so we will assume all these four values equal to 0. So in this equation, put U2 equal to 0 and U3 equal to 0, you will get first iteration for U1. Similarly, in second equation, put U2 equal to 0 and U4 equal to 0, you will get first iteration of U2. Then again put U4 equal to 0 and U1 equal to 0, you will get first iteration for U3. And similarly put U3 and U2 equal to 0, you will get first iteration for U1. So this is how you can calculate first iteration. And why we assume all these values equal to 0? Because we don't have any other option, because we cannot apply directly standard 5-point formula or diagonal 5-point formula. Then somebody may ask, can we put other values, any other value except 0? So yes, you can use, and also you can easily guess from the table as well. So when you think about U4, so you just check the neighbor values. So neighbors are 0, 0, 0, 500, and here also 500. Remaining these are unknowns. So approximately you can take U4 close to 250 from our logical point of view. There is no issue. When you want to take value for U1, so check neighbor values 1000, 1000, 1000, 2000. Here also 2000. So you may say that we can take around 1500 value or 1200, that value you can, yeah, no problem, you can take based on your understanding level. Similarly for U2, you can take between 500 or 800 you can take, and for U3 you can take around 100 or between 100, 1000 and 1500, not 100. So based on the boundary value conditions, you can assume the approximate or initial values for U1, U2, U3, U4 based on your understanding level, and select the values in such a way that you need to do less number of iterations. So here we are assuming all four values U1, U2, U3, U4 equal to 0, and then put these values in equation u2 equal to 0, u3 equal to 0, you will get u1. Similarly, calculate u2, u3, and u4. So this will be your iteration number 1. So here you can see u1 is equal to 1 by 4. We put these two values equal to 0. The answer is 750. This is your u1. For u2, 750 plus 0 plus 1500. So what we did here, as we are using Gauss saddle, so for u1 we are using the latest value. So instead of putting, we have latest value 750, so that's why we are putting 750. Then u3, so u4 is 0. Then instead of u1, you can put the latest value for u1 as 750 plus 25 is 00, so u3 is equal to 812.5. Similarly, u4, so u1 you can write 562.5, that is the latest value for u2, and for u3 you can use latest value 812.5, 34 and equal to 343.75. So this is how we are assuming the initial values equal to 0 for all, and we calculate the first iteration u1, u2, u3, u4. Again, now you have all the four values for u1, u2, u3, u4. Then again, in this equation, put latest values and you can calculate the second iteration. So use these values and calculate second iteration, and then third iteration and fourth iteration, and you need to repeat this process until you get grid values and two successive grid values that have accuracy up to 2 decimal points. So let's say suppose iteration number 4 and 5, and if you compare these two values, then if you found the accuracy is up to 2 decimal points, then you can say that the fifth iteration is correct and you can stop there. So after doing iterations, we got the values for u1 1208.332, u2 is equal to 791.6661, u3 is equal to 1041.664, and u4 is equal to 458.33. So this is how you can reach up to the solution. So briefly, once again, I will repeat this problem and we will continue. Okay, so the mesh is given. So first step, what we did, we check is there any symmetry or not. In this case, there is no symmetry. Then we checked whether we can use standard 5-point formula for calculating u1, u2, u3, u4. So you concluded that we cannot use directly that formula. Then we checked whether we can use diagonal 5-point formula. Then again we realized that again you cannot use directly because in that equation there will be unknowns. So this is the problem. So that's why we decided to prepare the equations by using standard 5-point formula, and these are the four equations we got. Again, we can simplify this equation because we can take sum of these two values. Here 1500, here 2500. We can simplify. So just simplify these equations. So you will get simplified equations. Now the question is how to solve. We use correct formulas, that is standard 5-point formula. So what we decided initially assume all these four values equal to 0. So put u2 equal to 0, u3 equal to 0, calculate u1, put u1 and u4 as 0, you will get u2. Then put u4 and u1 as 0, you will get u3, and u3 and u2 as initial values and you will get u4. But as we are using the Gauss saddle, so initially you will get the first iteration for u1, and that you need to use in uh, while using the next formulas. So that the number of iterations can be minimized. But as I mentioned, instead of taking all the values equal to 0, you can guess what will be the possible values for u1, u2, u3, u4. So by assuming that values, you can also start. There is no problem. But if you have any kind of confusion, so take all the values equal to 0 and you can start doing iterations. So put initial values equal to 0, you will get u1 as 750. Then we have latest value for u1. So while estimating, you to put 750 as u1. Here 0, you will get u2. Again, while calculating u3, put latest value of u1, other value of 0, you will get u3. Similarly, you can calculate u4 just by putting latest value of u2 and u3. So this is how we can complete our iteration number 1. Then the first iteration values are available with us. So use that as a value for next iteration and continuously do the iterations. And how long we should do that? Continue till each grid value should have 2 decimal accuracy. So repeat this process till you get accuracy of the values up to 2 decimal points. And this is the solution: u1 equal to something, u2 equal to something, u3 equal to something, and u4 equal to. Again, if you check in the table, then you can say that u1 is less than the upper values, sorry, the left hand values, and or in other way you can say that it is the in between values for the mesh values. So initially we were thinking that we can take the value for e1 between 1000 and 1500. So again, your answer is also close to that value only. Similarly, you can check for u2. So u2 also, based on our assumption between 500 to 800, our guess was correct. It is 791. Similarly, for u3, we were guessing that it should be taken between 1000 and 1500. So our guess was correct, and the value is 1041.664. Similarly, for u4, yes, our guess is correct. So this is how you can assume the values appropriately in order to minimize the number of iterations. So that's it for from my side for this particular method. If you have any question,